Three spacecraft positioned millions of miles apart, a solar storm barreling through space at 2 million miles per hour, and for the first time in human history, scientists watching its every move in real time, tracking something invisible that could cripple our entire civilization. What they discovered changes everything we thought we knew about protecting Earth from the sun's fury. Welcome back. On March 28, 2022, the sun unleashed a massive coronal mass ejection, a billion-ton cloud of superheated plasma hurtling through our solar system. By pure chance, three spacecraft happened to be positioned at exactly the right locations: the European Space Agency's solar orbiter near Venus, the Bepicolombo mission traveling toward Mercury, and NASA's near-Earth spacecraft monitoring our planet. What happened next was unprecedented. For the first time ever, researchers could watch a solar storm evolve as it traveled through space, transforming from a compact eruption into an expanding wave of magnetic chaos. And the method they used? Brilliant. They weren't looking at the storm directly, they were watching cosmic rays disappear. Let me explain. Our solar system is constantly bombarded by cosmic rays, high-energy particles racing through space from distant supernovae and exploding stars. They're everywhere, all the time, like an invisible rain. But when a coronal mass ejection passes through a region, something fascinating happens. The storm's powerful magnetic field deflects these cosmic rays, creating what scientists call a Forbush decrease. It's like watching a shadow move across a wall, except the shadow is made of missing radiation. And that shadow tells you everything about the size, shape, and strength of the storm creating it. Dr. Gaku Kinoshita from the University of Tokyo led the research team. They combined data from all three spacecraft, each one measuring how cosmic rays dropped as the storm passed by. The solar orbiter saw it first, tracking the ejection as it left the sun. Bepicolombo caught it hours later as it expanded. The near-Earth spacecraft recorded its final approach. Together, these measurements created something never before possible: a three-dimensional map of a solar storm traveling through space. They could see it growing, twisting, evolving, and what they discovered was both reassuring and deeply concerning. The good news: solar storms don't maintain their strength. The March 2022 event started powerful. A G5 storm, the strongest category, capable of causing widespread power grid failures. By the time it reached Earth, it had weakened to G3. Still significant, still dangerous, but survivable. The bad news? We never knew this before. Every previous solar storm was measured only when it arrived at Earth. We had no idea how they changed during their journey. It's like trying to predict a hurricane's path by only measuring it when it hits the coast. Here's why this matters more than you might realize. Right now, today, the Van Allen radiation belts surrounding Earth are what space weather experts are calling fully charged. After repeated solar storms over the past months, these magnetic fields are saturated with energetic particles. One more major hit, one more powerful coronal mass ejection, and those particles could precipitate into our atmosphere. The result would be devastating. Satellites failing by the dozens, GPS systems going dark, radio communications disrupted worldwide, power grids overwhelmed. In 1859, the Carrington event, the most powerful solar storm ever recorded, caused telegraph wires to spark and catch fire. Operators received electric shocks. The aurora was visible in the Caribbean. If that happened today, estimates suggest $2 trillion in damage and electrical grids offline for months, possibly years. But here's the revolutionary part. With this new tracking method, we don't have to wait blindly anymore. The research team proved that by monitoring cosmic ray decreases at multiple locations, we can forecast a storm's strength and arrival time with unprecedented accuracy. Think about what that means. Warning time measured in days instead of hours. Utilities could shut down vulnerable transformers, satellites could enter safe mode, astronauts could seek shelter. Airlines could reroute flights away from polar routes where radiation exposure spikes during storms. The timing couldn't be better. We're approaching solar maximum, the peak of the sun's 11-year activity cycle. More sunspots, more flares, more coronal mass ejections. Yesterday, the sun produced an M2.2 flare, snapping back to moderate activity after a quiet period. Space weather forecasters predict G1 storm conditions today, January 18th, with auroral displays possible through the weekend. Nothing catastrophic, but a reminder: the sun is waking up, and we're not there yet with our defenses. The European Space Agency is developing a new mission called Vigil, dedicated exclusively to space weather monitoring. Launch is planned for 2031. That's 5 years away. 5 years during which we're increasingly dependent on vulnerable technology. Your smartphone, your bank, your hospital's equipment, everything relies on satellites and power grids that solar storms can destroy in minutes. What you need to understand is this: the March 2022 storm they tracked, Scientists now know it triggered the strongest geomagnetic disturbances since 2003. It disrupted GPS systems. It forced SpaceX to delay a Starlink launch. Farmers lost working days when their precision agriculture equipment stopped functioning. These weren't hypotheticals. These were real consequences from a storm we barely noticed because it happened to weaken before arrival. The cosmic ray tracking method works because the storms aren't transparent. They're thick, turbulent magnetic bubbles. And by combining observations from spacecraft at different positions, researchers can measure how that bubble changes shape, how it accelerates or decelerates, how it might split into multiple structures. It's weather forecasting for space, and we're just learning how to read the patterns. Here's my question for you, and I genuinely want to know what you think. We have the technology now to track these storms. We understand the danger, but are we moving fast enough? 5 years until Vigil launches. Decades of power grid infrastructure that wasn't designed for this threat. What do you believe should be our priority? More monitoring satellites? Hardening our electrical systems? Write your thoughts in the comments. I'm curious whether you think this is urgent or if we're overreacting to a rare threat. 3 Atlas taught us that interstellar visitors are real. This solar storm research teaches us something equally important. The space between here and the sun isn't empty, it's alive with invisible forces that shape our technology, our communications, our daily lives, and for the first time we're learning to see them. Thank you for watching. Until next time, keep looking up and maybe keep an eye on those solar forecasts too.